welcome everybody to the 10th episode of the PlainGains podcast. And today we have a very special guest, Tejas Kulkarni. Tejas, would you like to introduce yourself and give us a little bit of your background?
So thank you for having me, Juan. I'm Tejas Kulkarni. I'm from India. I'm completing my PhD in sports science and medicine, and my topic is lumbar spine mechanics of fast bowling in cricket. So cricket is a sport for those who are unaware of. I've done my MSc in sports science and medicine from University of Glasgow, and my bachelor's, the BSc in sports and exercise technology and exercise science from Sheffield Hallam University. So I'm currently in Mumbai, India, and I'm completing my PhD in sports science and medicine.
Nice. And how's that going? A lot of work so far?
Yeah, it's been busy. So
Yeah,
currently still working on the research design for my project and hopefully trying to get that in quickly.
it's really cool then. Well, I guess the first question I'd like to start with is something I see you talk about a lot is the foam roller. And
Yeah.
it's something very popular that we see at the gym, but there seems to be a lot of misconceptions surrounding it. So maybe would you like to explain the main purpose of the foam roller and what it does and does not do?
Yeah. So basically, it is propagated that foam rolling is used to release fascia or fascial adhesions or try to create this myofascial release. But fascia cannot be released from the force produced by foam rolling or the stimulation of foam rolling, because fascia as a connective tissue, when we think about it, it's supposed to be very tight. It's supposed to be very rigid. It's very rigid structure. Now that being said, it has shown to have some contractility, but that does not mean that foam rolling will cause any structural changes or significant structural changes in fascia. If you have seen a surgery or if you have gone through any surgeon's tools to cut the fascia or bring about any structural changes in fascia, they have to use very sharp drills or instruments. I think there was a study. I'm not able to recollect the exact name, but it suggested that approximately 900 kilonewtons of force was required, or equivalent force was required to bring about a structural change in fascia. But I doubt we can do that from foam rolling. So we are not actually bringing about any structure or releasing fascia through foam rolling. What foam rolling does is gives us a stimulus that feels good, that maybe distracts our nervous system from this stimulation or this perception of stiffness and pain temporarily, which helps us move. It's not causing any structural changes in the body.
Hmm, interesting. So the whole term myofascial release is kind of like a misconception then, right?
Yeah, I believe it is. And there's not enough evidence to say that fascia does get adhesions. So
Well, can is it possible for fascia to stretch, or as you said, you just need a lot of like force in order to do so?
fascia does show contractile properties. It's because of the cells known as myofibroblasts. So myofibroblasts are also in connective tissue and muscle, but these because of these cells, fascia does show contractility and does show change in length. But how apparent and how exaggerated that change in length is something that is yet to be researched. And if it forms adhesions is not clear. There's no evidence that suggests that fascia forms adhesions or any tissue forms knots or adhesions.
Interesting. So, for the people who aren't familiar, do you think you could kind of simplify the term adhesions,
Yeah.
for them to get a better understanding of what you're talking about there?
Fascial adhesions mean that fascia is a connective tissue, right? Like your tendons, like ligaments. So fascia is abundant through the body. It usually wraps around your muscle or is in the deeper layer of the muscle. So fascia, it's a continuous tissue. So between the layers of this fascia, it can sometimes bundle together or form lesions, and these are referred to as fascial adhesions, which are hypothesized or thought to cause that feeling of tightness, stiffness, or we found those trigger points. So all these are attributed to these so-called adhesions, but there is not enough research to suggest that this adhesions or these knots or these trigger points actually exist. It's more regarding how your nervous system has given you the feedback rather than there have been actual structural knots or trigger points prevalent there.
Absolutely. So I guess a question that would that I'm interested to know about would be if it's I believe well so difficult to stretch fascia, but as you said, has some contractility.
Yeah.
When we grow our muscles, would that stretch the fascia of itself, or what's really going on there? If you have any theories?
So theoretically, we can suggest a lot of things since the perimysium, epimysium are kind of referred to as fascial tissue. The collagen the tendon when it's going through its length does is basically fascial tissue that is being differentiated. But when we talk about muscle hypertrophy, could there be increase in this fascial? Because when we are growing the extracellular components, the contractile components of the muscle, yes, I believe there is a scope for this fascial length to change with hypertrophy, with atrophy. But I don't have any or cannot recollect any research papers or have any evidence from my side to prove that this actually happens to a certain degree.
It's definitely just an idea out there because I think sometimes I think to myself, I don't really know the answer. I've heard before that there is different types of fascia.
Yeah.
Um, if maybe if you could expand on that, if you're aware of what I might be talking about.
So there is loose fascia and thick fascia. They are differentiated based on where they are prevalent. So one type of fascia would be near your muscular tissue, your connective tissue, joint, ligament, tendons, while other would be near the organs. So that is the way they categorize fascia.
Cool. And so, I guess we could do like a quick practical takeaway before moving on to the next topic. What would you say would be an ideal reason to why people should foam roll? And if they don't think that foam roll is really doing what they think they're doing, should they still be foam rolling out of enjoyment? Any thoughts on that?
Yeah. So if you like it, do it is what I would say. And there are psychological benefits of foam rolling. For if you feel tight, if you're going for a competition, right? If you're into a competitive sport or a competitive activity, and you feel tight, you feel discomfort in a particular region, and you might attribute that to multiple things. But if foam rolling gives you a temporary relief so that you can do that movement or do that competitive activity to complete that competition or tournament, then yes, you can use foam rolling in in those situations. But with foam rolling, usually it is suggested if you like it, you do it. There's no such apparent disadvantage to foam rolling. Just the thing that foam rolling acts like a, it's not exactly accurate, but kind of acts like a painkiller that distracts the nervous system. Now, we cannot really compare painkillers and foam rollers, but foam rolling distracts the body from the original problem. So we tend to neglect the original problem of why we are feeling sore, why we are feeling pain, why is it stiff, and just use foam rolling as if that foam rolling's causing any recovery or becoming an intervention of sorts. So my suggestion is to foam roll if you like it, but also address the underlying causes of tightness or stiffness, like managing your workload, managing nutrition, stress, sleep, and understanding how much you can tolerate and working in those tolerable ranges.
So it's kind of like a band-aid, right? That people like to believe that it's fixing the problem, but in reality, they're not targeting the main reason they have that sort of sensation or stiffness.
Yeah, I would like to believe that. Yeah.
Yeah. Okay. Well, then moving on to the next topic, a big one actually as well. Insulin. A
Yeah.
lot of people seem to have this whole idea on insulin and its weight gain or its properties on weight loss, its weight gain and in the body. And when you look at, nutrition, things can get very complicated. Well, at least on my side. Um, so maybe we could start off by going over what insulin really is and probably a big misconception that people, or that you believe, that you've heard a lot of people talk about, that isn't necessarily true.
Yeah. So basically, insulin is a peptide hormone that is stimulated by a pancreas in response to changes in glucose levels, mostly likely increased in glucose levels. But what I feel people are getting wrong is they tend to think that insulin is a problem or insulin release is a problem, which it is not. So insulin acts to reduce blood glucose levels. So whenever there are rise in glucose levels, insulin is stimulated by the beta cells of the pancreas, and then insulin binds to certain cell receptors. For example, let's take the example of the muscle here. So there is a insulin receptor which is suggested at IRS in the muscle. So insulin receptor substrate, and that binds with the insulin, and then glucose entry into the cell occurs. Now that happens because muscle requires GLUT4, that is glucose transporter 4 action. For glucose to enter the muscle, glucose transporter 4 action has to take place. And glucose transporter 4 is insulin dependent. You need insulin for glucose transporter to work properly. So for glucose to enter the cell and then be converted into ATP or glycogen, you need insulin. So the misconception here is insulin release itself is the problem, or a lot of insulin release is the problem. I would say it's not as simple as that, that just an insulin spike is the problem. It's the way the muscle handles the glucose that has been released in the blood, how insulin sensitive the tissues are. So when we talk about type 2 diabetes, insulin resistance, now this is not exactly an accurate like to like comparison, but in case you ingest 10 grams of carbohydrates, let's say it's completely glucose, you would require about some certain amount of insulin for that insulin spike for that glucose to enter the exercising muscle. But if you are insulin resistant or you are suffering from type 2 diabetes, then you would require uh, more insulin for the muscle to utilize the same amount of sugar. So when we speak
Okay.
about insulin, it is an anabolic hormone, right? It stimulates proteolysis. It stimulates satellite cell differentiation in the muscles. So it is important. It is demonized beyond a certain aspect, which I believe is not right. It The body functions. It has certain mechanisms in place. It has certain cell signaling mechanisms in place to modify or really regulate all these functions or the disadvantages of whatever we say insulin spike. While that being said, we have to also understand if insulin was not there or insulin function is hampered, it hampers all the other activities. Because insulin is required for many of for glucose entry into the cell for many of the organs and tissues.
Wow. Okay. So would you, if someone comes up to you and they say, well, insulin is the reason why I still haven't been able to lose weight,
Yeah.
or it's very difficult for me to lose weight, or it's the reason that I'm gaining weight, it's not about calories in, calories out, what would be like a response for you, that you would tell them about that?
Right. So what happens with weight gain is insulin, as we all know, will stimulate fatty acid uptake in the adipose tissue. So insulin is required for triglyceride to be stored inside fat cells. So insulin is not the cause because your body stores fat and burns fat continuously for a 24-hour process. Our body doesn't understand that it's Monday or Tuesday. Your body will continuously store fat, will continuously burn fat. The rate of fat burn and fat storage will depend on hormones, one of them being insulin and glucagon. So if insulin levels are high, your body will tend to store more fat. But that's time sensitive, condition sensitive. While other occasions, whenever during exercise, post exercise, that can be altered. When durations of starvation stage, when you're not actually eating anything, or post fed state, when you're not eating anything, that time glucagon levels might be higher, insulin levels might be low. That time your rate of fat burn might increase. So through this calories in, calories out process, we're kind of estimating how much energy are we producing, how much energy are we burning, and through that gap in energy or through that deficit or surplus, we can predict, okay, this is increasing rate of fat loss, this is increasing rate of fat storage. So that way we can predict changes in body composition. It's a predictive model. Again, we can't really completely accurately know, okay, this is the amount of calories are being burned, because there is energy lag, there is some dissipation of energy required in all those energy producing processes. But when we talk about when we speak about fat storage specifically, there are certain mechanisms that do not require the action of insulin, or do not require a significant change in baseline insulin levels. So there is a hormone known as uh, acylation stimulation protein, that is ASP. So acylation stimulation protein can uh, increase the uptake of glucose and fatty acids in the fat cells. And this acylation stimulation protein is influenced by the amount of fat cells also. So those are kind of, you can say, independent of insulin. So you can store fat even if insulin is not present. So blaming insulin alone for fat storage is not right.
Okay, well, I think that puts that kind of helps gives a better clarity on the idea, because social media is now about it's all about insulin. It's all about insulin. One thing that could be that I do find interesting is a lot of people wonder about. Have you heard of like beer bellies? About how
Uh,
some people may have like a lot of fat stored in one area but are skinny all around. Uh, if you're familiar with that, maybe you could touch on what could be happening there. Is it just fat stored in that area? Is it anything? Does it have anything to do with hormones?
yeah. So yeah, I would admit that I'm not completely familiar with the literature on this particular situation. But what I can think of is, yes, altered fat storage, basically more visceral fat, then more visceral fat in one particular area, one particular organ. So with alcohol, you can see more fat deposition at the liver. Then altered Krebs cycle activity. So multiple things. Alcohol does influence a lot of organ systems, a lot of hormonal systems and hormonal balance. That's why, yes, it could be that maybe fat deposition increases in one particular area. Now, could be, this is just me talking from a completely theoretical perspective. Then there could be associated bloating, associated water retention in one particular area or the other. So that could be the reason why people suggest that this is a beer belly or a pot belly, rather than, while all the other uh, areas are not that fat or do not have as significant fat deposition. So this is just my hypothesis and theory. I would like
Yeah,
to
I'm
know.
very I'm very glad you keep mentioning that, because a lot of people take things. A lot of people start to take things and make sure that, oh well, he said this is 100% real, but you're always clarifying that there's either research on this is still a hypothesis, a theory. So I think it's really important that people make sure to not skip that part of what you're saying, because then that can go and just create, I guess, sound bites, what some people call them, and lead to this whole misconception on social media. So, well, I guess one more thing on insulin. Um, so when someone would say it's only about calories in, calories out, I mean that's pretty much the fundamental process of whether you gain or lose fat. Do you think hormones may have any role in that? Even like still considering calories in, calories out being the fundamental base. Do you think alterations in hormones can create, notable alterations in the body?
Yes, I do. But if we equate everything, genetics included, if we equate everything, if we equate calorie burn, calorie ingestion, calorie, so basic height, weight, etc., everything, if we just keep that same, then hormones will play a role, yes, because some of them are more anabolic, that will stimulate more lean muscle growth. Some of them can initiate a more catabolic response. So when we talk about, now there's also certain aspects to what is the extent. Now, unfortunately, I can't really quantify that, because everyone will have a different receptor or stimul or different extent of how they bind with that hormone receptor and how that action takes place. Then the enzyme regulation, uh, all the action of different enzymes, that will differ a lot at different quantities. But yes, there is. there is scope to be said that okay, if your everything kept equal or everything kept same, if there are discrepancies in hormones, yes, there will be a big difference, because hormones are what drive, they are chemical messengers. So what if hormones are in place, or there is good amount of ability of one particular hormone, then the chemical message will signal a different cascade of chemical reactions, and that is what will dictate whether there is an anabolic response. I'm just talking about in terms of hypertrophy here or fat loss here. That is, hypertrophy will be anabolic, fat loss will be catabolic. So, in those terms, yes, anabolic response can be heightened and catabolic response also can be heightened. Catabolic in the sense of fat loss and anabolic in the sense of muscle hypertrophy, because catabolic can also mean muscle loss or protein
Yeah, right,
degradation.
right,
So,
right.
I have one more
Um,
point to add regarding these hormones. If I can do that, is that okay?
I'm sorry.
Can I add another point to this? So, to the
Yeah,
insulin,
absolutely.
yeah. So, since there are multiple signaling pathways, like if you have heard of mTOR pathway, the AMPK pathway. So, mTOR pathway is necessary for muscle hypertrophy. That signaling mechanism is what drives protein synthesis. So, hormones influence those signaling pathways. So, if the hormonal action or balance has been inhibited by some aspect, then that cell signaling pathway also, to a certain extent, is influenced.
Okay, interesting. Yeah, and don't feel afraid to not go a little in depth and get nerdy. That's kind of what we do, or what we like to go for in these podcasts,
Thank
while
you.
still having people, stay on track with what we're saying.
Yeah.
Um, so, are you familiar more with these pathways on hypertrophy and hormonal pathways? I guess so. For the AM, what was it you said, a PK pathway?
Yeah.
Maybe you could expand a little bit on that, just for people who may be interested.
Yeah, so AMPK stands for activated adenosine monophosphate kinase pathway, and mTOR pathway is mammalian target of rapamycin. So they are dependent on a lot of factors, but one of those factors that I can explain properly is energy availability or ATP availability. So ATP is adenosine triphosphate, the energy currency of your body, and ADP is adenosine diphosphate. So diphosphate means two molecules, triphosphate is three molecules of phosphate. So ATP is considered as an energy rich environment. ADP or AMP, which is monophosphate, diphosphate, one or two molecules, is considered as an energy deprived state. So whenever ATP availability is in good amount, that time mTOR pathway is stimulated. mTOR pathway will then stimulate protein synthesis. That's why amino acid ingestion post exercise, whenever there is less energy availability, giving energy in the form of glucose, amino acids can stimulate the mTOR pathway. So one of those mechanisms, only one of the multiple factors here. There are more than 100 factors. Biochemistry is very complex in that regard. But ingestion of protein, ingestion of carbohydrate, ingestion of energy, basically in any form, will stimulate mTOR pathway. That's why mainly leucine, the branch in amino acids, leucine, isoleucine, valine, are suggested to stimulate this to a greater degree. Now, this is a hypothesis again. I believe all essential amino acids will stimulate the mTOR pathway. And AMPK is activated or more prevalent in energy deprived conditions. So when your ATP availability reduces, that time AMPK activity increases. AMPK is
Absolutely.
also important in regulation of hypertrophy or regulation of growth, basically.
Yeah, absolutely. Definitely agree on some of the points you made there. That it's not one factor; it's a very multifactorial process. Um, well, speaking on biochemistry, there is this whole thing on lactic acid going around. And now people are saying that it doesn't necessarily exist in the body. Some are saying it can decrease your pH, which we'll get into that a little bit if we can. Um, so maybe you could expand a little bit on this whole lactic acid thing. What is it? And does it exist in the body, or at least in very small amounts, or what really happens to the lactic acid if it's in your body?
Yes, so lactic acid, or we sometimes use these interchangeably with lactate, but that's not completely accurate. So lactic acid is kind of formed in the body when you exercise. Even at rest, it does occur. So lactic acid is a byproduct. I wouldn't say a byproduct. It's a product or metabolite that is generated via anaerobic glycolysis or anaerobic respiration. So anaerobic means whenever there is glycolysis taking place, that is a glucose molecule is being converted into pyruvate. That pyruvate gets converted into lactic acid or lactate. We'll use this interchangeably for now. I hope that is okay. It's slightly inaccurate to use lactate and lactic acid together interchangeably, but I hope that is all right for now. So when we talk about lactic acid or lactate being formed, many people think that this is a waste product, but that is not a waste product. Now, even at rest, you are generating small amounts of lactic acid or lactate, because anaerobic respiration to a very small extent is still taking place at rest. We are sitting here, anaerobic respiration is still taking place. So lactic acid or lactate is being formed. Now, aerobic respiration in that regard, where the pyruvate then enters the Krebs cycle, then enters the electron transport chain, then through ATP synthase, ATP is formed. In that regard, lactate is not formed. So we get multiple hydrogen ions, we get oxygen, we get carbon dioxide from that aerobic respiration through all these processes. And of course, we get ATP. But those are kind of more of a waste product. If we want to call these waste products, then those are what we tend to think of as byproducts or waste products of that metabolism, not lactic acid. Because lactic acid that is generated by anaerobic respiration is then utilized to create energy. So lactic acid in the muscle itself can be converted to pyruvate, and then that pyruvate could enter the Krebs cycle, electron transport chain, and then be utilized to create ATP. Or it can enter the Cori cycle, where that lactate will go to the liver, and then gluconeogenesis can take place, and lactate will be converted into glucose, and then that glucose will again be released into the bloodstream, and it can enter the muscle to be utilized as energy or be stored as glycogen. So lactate is an
Yeah.
energy substrate. We create energy from lactate. It's not a waste product.
And could you explain the difference between lactic acid and lactate? Because as you said, although they're used interchangeably,
Yeah.
it's not completely accurate.
So lactic acid gets converted into lactate under certain conditions. So it's like a pre-product, if I can say that. It's a precursor, basically,
Okay.
kind of precursor.
And it's I know based on their chemistry, lactate is the one that is lactic acid minus the hydrogen ion, if I'm correct.
Yes, yes, yes.
Yeah. So, well, going into that, hydrogen ions are very acidic, correct?
Yeah.
So, what are you familiar with? What can really decrease the pH in the body, and if that's really caused by lactic acid?
Yes, so your body has buffer systems in place. It has different mechanisms. So availability of carbon dioxide, availability, sorry, not carbon dioxide, availability of carbonates, so HCO3. It's one of the buffers that are available in the body. Now your kidney does play a big role in acid-base balance. So bicarbonates will try to interact with these hydrogen ions, will interact with the carbon dioxide. And if certain quantities of each or other increases, maybe if carbon dioxide quantity increases, it reacts with this bicarbonate, then we get carbonic acid, which then increases the pH significantly. Of course, with simple exercise, simple movement, you tend to influence the pH, you tend to influence the temperature in the muscle. But when we talk about making a significant change or making the environment more acidic, one of the mechanisms could be that this bicarbonate and ion is getting interacted with maybe carbon dioxide, through which it is getting converted into carbonic acid. So the ability to buffer or maintain that acid base balance is being reduced.
Yeah, and I think it's important to mention that this whole biochemistry in the body can get very complicated. So don't just think it's one thing that happens all the time. There's many other factors that can play in. Um, and maybe going back a little bit to the basics, for the people who are interested, could you explain what a buffer in the body is and maybe go over the pH of what we mean when we say pH in the body?
Yes. So I'll start with pH first. So pH is potential of hydrogen. So it has a certain numerical scale attached to it. So if it's below 7, it's considered to be acidic. It's above 7, it's considered to be alkaline, or it's considered to be basic. So we use litmus tests in the lab to see if it's acidic or basic. They change in color of the litmus paper and then look at the color scale and then attribute numbers to it. So that is one way if you are interested to know about pH. And then of course there are other lab methods as well, but this is the simplest method to start with. Then when you talk about buffer systems, it's basically to manage the amount of acidity or alkalinity in a particular area or in a particular system, or it could be even blood. It won't be accurate to say blood. So that buffer can be a compound that reacts with another compound, so that the influence on acidity or alkalinity of the uh, substrate will not really influence the working or interaction in that organ or in that area.
Okay. Yeah, absolutely. So, just we just I wanted to touch on that for people who maybe have taken chemistry before but forgot what those terms are a little bit. Because I hear a lot of people talk about pH, but they forget what it really stands for, and potential hydrogen, which is pretty interesting. Um, so going over the decrease in pH and well, the muscle cells, would you say that lactate is more of a friend, or is it more, is it something that we should, or friend or foe, I guess we could say?
It not that simple to be honest, because that will depend on the type of activity, the duration of the activity, and of course how active or how efficient your energy systems and enzymes are. When I say that, because when you talk about a marathon or a sprint, there are of course different energy systems involved, right? So with sprint, it could be more anaerobic dominant. You can have the creatine, phosphocreatine system involved, the anaerobic system involved to a greater degree than the aerobic system. We talk about the marathon running, it would be a greater involvement of the aerobic system than the anaerobic system. So when you talk about, I've taken two extremes here, but when you speak about slightly increasing the duration of a high intense activity, maybe you're at 70 to 80% of effort, but you're doing that activity for a minute or two. Let's imagine that's happening, and due to lactic acid being formed from anaerobic respiration, the contribution of aerobic system has increased, but not very much. But the aerobic system increase will likely result in greater transport of the lactic acid into the through the bloodstream. So the ability of lactate to be cleared increases with increased contribution of the uh, aerobic energy system. So of course, even if, like, the example of the marathon running or long duration exercise activity, that time aerobic system activity is pretty high and anaerobic system activity is pretty low or moderate. We can say low to moderate. But at that juncture also, after a certain amount of duration, the ability of this lactic acid clearance reduces. That is why when the lactate accumulates, that we tend to use the term as blood lactate threshold, uh, then the ability of this lactate to get cleared to be utilized as energy reduces. Then that is when we can say that the pH of the muscle is influenced, the ability of the muscles ability to produce force is influenced. Then the ability to continue exercising is influenced. So this will depend on the energy system. Firstly, what energy system contribution is prevalent, what is the type of activity, what is the duration of activity, what is the goal with doing that activity.
Yeah, and I'm glad that we keep touching on this because you are pretty much asking the proper questions when you receive such a straightforward question where it's like, well, is lactic acid your friend or not? And it's like, well, I mean, it depends. I mean, it's very complicated stuff when you start to look at it. A lot of people, again, social media, big influence on this. They think it's just a straightforward answer, and they think it's like, well, lactic acid doesn't exist, or lactate is your friend, and that they just keep it at that without really knowing all the mechanisms behind it and a lot of influences that you said that can occur. And I'm pretty sure I guess we could put this myth to an end where I would hear a lot of people say that foam rolling can, I guess, reduce or just push away lactic acid in the body. Maybe you could just finish off that myth and really say what's going on because they're like, oh, well, I have a pump or something, and I feel like the foam roller takes away the water, or whatever, the pump or the lactic acid quotations that's in there.
So I gotta admit that I'm not really familiar with this mechanism or this any research on this particular topic, but I can say that we could influence that by increasing blood flow in that area. So whenever we foam roll, we are trying to increase blood flow to that area. This will be again time dependent and tension dependent. If we foam roll a very sensitive area like the popliteal fossa, for example, if we foam roll for a long period of time, it could actually cause very negative consequences. There, because if the capillaries are pretty thin and it's a sensitive area, so foam rolling for a longer duration could actually cause damage to some of those capillaries. Then increasing when you say having a pump, right? So there's already a lot of inflow of nutrients. There's a lot of mechanisms are taking place inside the muscle. So adding foam rolling would help with the sensation of discomfort that is if that is arising from the pump. So that could modulate that for a short time. Or if there is any restriction or if there is any scope for added blood flow to that area, foam rolling will add some extra blood flow or will transport more blood to or ask the more blood to flow to that area. That is what I feel is happening when you talk about pump and foam rolling.
Mm. And yeah, it's always good to just get like a different perspective or maybe just someone's other ideas on what could be happening. Um, when you say foam rolling for a long period of time, and we're doing full circle here, going a little back to foam rolling, it could compress capillaries, or why could that be a bad thing? Is that the only thing that could make it not the best thing in the world to foam roll for a while?
Uh, there are some, I wouldn't say some case studies to look at. They're not documented pretty well though, but that there's some research to suggest that foam rolling can actually damage blood vessels, capillaries in very sensitive areas. So the popliteal fossa being one, then the underarm region being another. Now, with certain people, uh, they can tend to damage a lot of other sensitive structures. For example, their brachial plexus, and but that is not documented in research. This is just a few uh, cases that I've gone through. I've communicated with a few people that have had those experiences, and when they stopped foam rolling, when they tried exercising well, managed everything else in their life well, then that problem really went away. But we have to go through more research, or there is scope for more research in this area. Can foam rolling actually affect the brachial plexus if we foam roll near the underarm or near this soft neck, near the neck region? So the subclavian artery and the brachial plexus moves through the anterior, middle, and posterior scalene muscles. So between that space, the subclavian artery and the brachial plexus run through. So if we kind of do those soft tissue muscles, are we actually influencing the structure or influencing those important things in our body? So there is scope for research to take place on this. Now that means that this pain and injury is not very well correlated. So don't take my word for it for now.
Yeah, I remember I've read like some, I don't know if they weren't research papers, they were like blogs, and they were, and it's always careful to watch out what you read with blogs because you'd find blogs that say completely contradictory things. And they would say that foam rolling can compress the capillaries and reduce blood flow. I personally haven't looked into anything of it, so I'm not so familiar on that. But as you said, there's like some documented research, not fully sure on it, right?
Yeah.
Yeah. So there's that. Just wanted to touch on that because I remember reading about it and I was like, well, it sounds interesting, but I don't think I've seen much on it. Um, well, before we could I guess, wrap up, is there anything you'd like to add on your part on either topic, on foam rolling, or what happens in the muscle that you may have left out in the beginning?
Yeah, so I would say that coming back to the sensitive areas thing, so there is still scope for more research, right? So if there is a possibility of there being negative consequences of a particular activity of intervention, like foam rolling, for example. So why would you want to risk by doing foam rolling in the sensitive structures? If there is no research yet, maybe further research is coming, and maybe it will show that there is no negative impact. But if there is, why would you want to risk it? Even if there's a chance that you might be damaging sensitive structures in your body, I believe we should not experiment and try to damage those sensitive structures in the body. Let's this can be a bit. This might seem a bit conservative, but it's always better to be safe than sorry, right? So my suggestion would be to avoid those sensitive areas to foam roll. And if you want to foam roll, I personally don't foam roll. But if you like to foam roll it, you can foam roll for a short duration. Just that, don't think of foam rolling as creating like a healing environment for your body. Foam rolling is not recover or causing any changes in recovery. It's just the psychological benefits of foam rolling making you think that foam rolling is actually doing something. Even with range of motion, we didn't really touch on the range of motion and foam rolling correlation. So foam rolling can increase range of motion temporarily, but whatever changes in the range of motion that were observed were again observed for a very short time. So when we speak about range of motion, again it gets very very complicated when you want to talk about range of motion. So range of motion can be most likely inhibited by neurological mechanisms or structural limitations. With structure, we can't really do much, but with neurological mechanisms, as you add different exercises, as you challenge the muscle at different lengths, you might get that flexibility benefit. But foam rolling giving you that certain sensations or stimuli can temporarily change the sensitivity of the mechanoreceptors of your body. So when mechanoreceptors, you can look them muscle spindle and Golgi tendon organ are the mechanoreceptors of interest in this particular discussion. So when we foam roll, we change the sensitivity of these structures as well as the sensitivity of the nervous system of through which the motor, mechanoreceptors respond to. So while using this foam rolling, that can temporarily change the sensitivity, which might give this perception that you have increased range of motion. But that lasts for a very short while.
And would you say that, or what are your thoughts on the idea that people foam roll to get this temporary range of motion to then train in that range of motion? Do you think that might be beneficial in any way, or would you say that you still wouldn't really need the foam roller?
For general fitness, just increase, getting fitter, getting healthier, I wouldn't recommend doing that. But if you're into something that is competitive in nature, that if you don't get that range or don't achieve that range of motion, then you might not succeed at that activity. Then yes, you have to weigh the risk and reward in that particular situation, and then choose the appropriate thing to do. But with general fitness and health, I wouldn't really recommend doing that. So because if there
Okay.
is a limitation in range of motion, there is obviously a reason for that limitation, right? Your body isn't just going to limit range of motion on its own. So maybe because your body is not, maybe there's a psychological factor, confidence of getting into a range of motion. Then there are neurological inhibitions. I think you have a video that touches on that neurological aspects of stretching, I believe, on YouTube.
I believe so. I did talk on some of these stretching things where it can be structural, but sometimes it can be it could be neurological, structural, yeah, and maybe psychological even. Actually, I don't know. I haven't looked at too much into psychology of stretching. Um, but I wanted to come back real quick to something you said, that some parts of the body just aren't necessarily meant to be loose. There are some muscles in the body that are meant to be tight. And a
Yeah,
big one would be like the TFL that a
yeah,
lot of people try to foam roll, but in reality, you want that part of your body to be tight and support the structure, correct?
yes, Yes, absolutely. So the TFL muscle is required for you need that to be really tight and stiff to prevent to get that structural integrity in place, especially when doing impact activity. So it is supposed to be stiff. You are absolutely right about that.
Okay, good. Just wanted to make sure on that. And that's not the only muscle. I mean, there are different muscles in the body that, as you said, maybe around in the upper area. Um, I know a lot of people say do not foam roll the lower back. It's more so the upper back that you would go for the foam rolling. Do you may have an idea of why you wouldn't, why you would want to stay away from foam rolling the lower back?
It is suggested that because the scapula is present at the mid back, upper back, the compressive forces don't really cause an issue, and at the lumbar spine there isn't really any other supportive structure. I don't think that's the case. It could be a factor, but in that regard, then you should not foam roll the upper back as well, because you are adding compression from the scapula as well as from the foam roller to the vertebra. So I'm not really a big fan of foam rolling the spine, any area of the spine, to be honest.
Mm. I haven't thought of it that way. So that was a cool little uh, thing to think about. Well, I guess we can end with a quick conclusion on. Well, we kind of concluded already on the foam roller, but maybe on insulin and lactic acid. If you'd like to just summarize it real quick
Yeah.
um, for the people listening.
Yes. So if you're healthy, if there are any associated metabolic disorders, and you're active, you don't need to fear insulin or insulin spikes, so-called insulin, so-called insulin spikes, which are supposed to be terrible for you, are not actually terrible. Don't fear the rise in insulin levels. Don't fear insulin. The mechanism of insulin is important for your bodily functions. And with lactic acid is kind of a gray area, depends on the uh, exercise intensity, exercise duration. But lactic acid is not a waste product, and if you develop basically the burning sensation, or when you're not able to produce the same amount of force that you used to at a particular juncture, it's most likely better to stop rather than thinking about optimizing uh, buffer systems or optimizing that lactic acid. That will happen. That is an adaptation that will occur with time.
Okay. Great. And I do want to add for the people listening as well, if they're interested. You have a nutrition course, or what? You have like different courses that go over pretty much a lot more in depth in the topics that we have here. So if you guys are very interested, maybe you want to expand a little bit real quick on what you go over in the course.
Yeah, that would be my pleasure. Thank you. So currently, I have an exercise science course running where we talk about the basic concepts of biomechanics, and we kind of add some complexity to those concepts as well. And we also talk about exercise physiology. But that course is coming to an end. But I'm starting my nutrition science course where we touch on some biochemistry. We'll touch on modifying different vitamins, minerals, modifying macronutrients according to your goals, understanding how nutrition plays a role in different scenarios, the different interactions that could take place with different nutrients. So we will cover the biochemistry aspect. We'll cover how nutrition can affect different things, like for example hormones, for example sleep. Then there's something known as anti-nutritional factors, or anti-nutrients for short. How can they affect the human body? And then I also have some segments on supplementation, sports nutrition, where we'll talk about how to optimize pre and post exercise nutrition. There will be some strategies involved, and that's about it, I guess. I think there will be more than 50 lectures in that course, so I'm trying to make it a bit comprehensive one. And
Yeah,
thank
it's
you so much.
a lot of knowledge, a lot of knowledge in that course. So, if anyone is interested, or if anyone is interested in just learning more about Tejas, I will make sure to put down his the link in the description below on his social media in the description, and that pretty much wraps it up for today's video. So, as always, like, subscribe, and thank you guys for listening.